Okay, this is video number 3 of sections 2223. This one's mainly about notation, about reading things, and about a formula that should be familiar from Algebra 1. But we're going to start by reviewing some notation. Make sure that you go back to the other video to recall that there's several ways we can ask you to find the derivative, right? These are the most common ways. I could ask you to just find f prime of x. F prime of x. That's the symbol for finding the derivative at a specific x value. Or I could ask you to find dy over dx, right? The derivative of the y equation, because y is f of x, the derivative of the y equation with respect to x, meaning my equation is in terms of x. It uses x variables. That's what the symbol means. The derivative of the y with respect to x. Or since y is f of x, we can just say find y prime. Now, if you go back in history, there's different ways of doing derivatives. I think Isaac Newton used to use dots, like this is the first derivative, here this is the second derivative. These little dots on top of the formula name. I know there's some other symbols that go find the derivative with respect to x of whatever the formula is. But these are the most common ones that we see in any college course, college calculus course, and on the AP exam. Remember that the derivative tells us that we are finding the slope of the tangent line, the line tangent, to a given function at a specific point, right? The whole idea behind the derivative is that we're looking for the instantaneous rate of change. So sometimes, if you recall, I'll go back to the example that we were looking at in the previous video. Sometimes we're looking for the slope of this purple line, right? Or the orange line or the green line. But I would like to know the equation that would create this purple line so that I could graph it at the same time as the actual curve and see that it actually meets there, and that they definitely share a point, because it's a point of tangency here, and it also shares the slope, right? So there are formulas that we use to create the equations of those tangent lines. Remember, a tangent line is just a line. So therefore, going back to Algebra 1, you talked about two different things you need in order to create an equation of a line. You're always going to need a point, and you're always going to need a slope. If you know those two things, you can create the equation of the line. Now, if you think about how we've been talking about things in terms of point, we've been talking about points in terms of this is my x value, this is my y value, and I have a point, right? So my x is this value, my y is my second coordinate, this value. And what we just said is that the slope is the derivative. So therefore, another way to write that is we're looking for the derivative at x equals a. So the derivative is the slope of the tangent line, and the slope of the tangent line is found at a specific point. Excuse me. So therefore, I can write the equation this way. Y equals f prime of a, which is the slope, times x minus a plus f of a. And if you remember, or maybe, I don't know if you remember, that your Algebra 1 teacher, probably told you y minus y1 equals m times x minus x1. If I add this to the other side, I create the point slope formula to find the equation of any line, as long as I know the slope, which is what this is, and as long as I know an x and a y coordinate, which is what this is. So we need an x and a y coordinate. We need the slope. As long as we have those two things, an x coordinate, a y coordinate, and the slope of that line, we can create the equation fairly quickly. Okay, let's do it. In example 1, A function f is continuous and differentiable. We haven't talked about differentiability, but differentiability means that the derivative exists for all values of x in this case. So the function is continuous. That means there are no holes, there are no breaks, there's no gaps, and it's differentiable. I can find the derivative value, the slope of the tangent line at any number. It is known that f of 4 is 7 and that f prime of 4 is 2. Can you write an equation of the line tangent to f of x at x equals 4? Well, do I have an x value? Do I have a y value? My a is 4. My f of a is 7. This is like my x. This is like my y. I have a coordinate pair. I also have the slope. The slope is 2. So I can write an equation using this formula that's in the box. Y equals the slope, which is 2, times x minus the x coordinate, which is that a value, which is 4. Let me use that color that I used over there. Plus the y value at the x value that we found, which was 7. This is the equation that will draw the line that is the tangent line that they're talking about. That seemed pretty easy. Maybe. I don't know. Let's find out. The function g is defined as this equation. It is known that the derivative of f is defined as g prime of x equals 2x minus 3. Write an equation of the line to g of x as x equals negative 1. I think there's a typo here. This should be the derivative of g is defined as g prime, because the derivative of g would be g prime, is equal to that. Write an equation of the line tangent to g of x at x equals negative 1. Great. Do I have my two things? Do I have a point? Do I have my a value? Well, my a value is the x value, so that's negative 1. Do I have my f of a value? Do I have my y? Well, no. However, they tell me how to find it because they give me a formula that'll find any value that I want as long as I know the x value. Since this is g, let me do g of a, or g of negative 1, I guess. That would be negative 1 squared minus 3 times negative 1. Let me move this up. Plus 5. Using your calculator, using your brain. Let's see, negative 1 squared is positive 1. Plus 3, that's 4. Plus 5, that's 9. So I have my x and I have my y. I have my a value and I have my g of a value. Just over here, just like over here, they had given me the a and the f of a. I have the a, in this case, the g of a. Great. Do I have the slope? Well, I don't have the slope, but I have a formula that can help me figure out the slope. So if I'm looking for g prime of negative 1, well, that would be 2 times negative 1 minus 3. This formula will help me find the slope because that's what it says. To find g prime of any x, multiply 2 times your x value minus 3. Well, 2 times negative 1 minus 3 will give me negative 5. I have my slope. I have my point. So I can write my equation. My equation is y equals negative 5 times x minus your x value, which is negative 1, and that's going to change it to plus 1, plus my y value, which in this case is 9. Do you see how we're just using the formula that's there? And actually, it's a formula that you learned in Algebra 1. You used y equals mx plus b probably more often than you did point slope form. Point slope form looks like this. But it turns out point slope form is a little bit more versatile because it allows you to find the equation of the line that we need in order to, with just a point and a slope. So before I end this video, I kind of want to graph this equation and graph the tangent line so that you can see we actually did in fact find the tangent line equation that's going to draw the tangent line at x equals negative 1. So I go to my calculator. Let's go to y equals. We're going to graph this. And my equation is x squared minus 3x plus 5. So I'm going to type in x squared minus 3x plus 5. Now you should know what kind of graph that makes. That's a parabola. That's a quadratic equation, so that's going to create a parabola. And then my tangent line equation is negative 5 times the quantity of x plus 1 plus 9. Negative 5 times the quantity of x plus 1 plus 9. Negative 5 times the quantity x plus 1 plus 9. All right. So I have both of my equations there. Y1 is going to draw the original graph. Y2 is going to draw the tangent line that barely touches the original graph at negative 1. I'm going to do a zoom. Let's see if I can zoom in a little bit. I'm going to do a zoom 4. There's the original. Oh, I shouldn't have done that. So let's do a zoom 6. There's the graph. There's the tangent line. I'm going to change the window a little bit. I'm going to move up so that we can see more of it. Let's go to 20. There's the curve. There's the tangent line. And if I trace at negative 1, that red line is only touching the blue curve at that one point. They share that point in common. This point, negative 1, 9, is on the red line and it's on the blue curve. But more importantly, the slope of the red line is the slope of the blue curve at that specific point. We just found the tangent line whose slope is the derivative value of the blue curve. That's what we just found. We'll come back in the next video and we'll do some more practice.